Okay, we see here the cassette case filled with Mountain Dew in this case. Mountain Dew being somewhat clear but also having some color so we can see a laser beam as it passes through. I can shine the laser beam and we can see several things. We can see the reflection of the beam here. We can see the beam as it passes through the water, or the Mountain Dew in this case, and we can see the beam as it comes out the other side. We can change the angle somewhat drastically here, and we can clearly see that the angle of the beam through the Mountain Dew is different than its angle as it comes out of the Mountain Dew, so that we see that the beam is indeed refracted as it goes through the Mountain Dew. Now, we can trace these rays. If I hold the laser pointer still here and position it so that I can see everything. Now really I should have the laser pointer resting on something, but if I mark the paper here where the laser beam comes out, and really I should have the laser back a lot further so that when I mark it I have a more accurate line. Okay, I mark it here where it enters the glass. I mark it over here where it exits the glass. Then I mark it here along the beam. Okay, you might not have seen that. Let's say I mark it at this point along the beam that comes out of the glass. If I then trace the outline, or at least two sides of the outline, preferably all four, of the case, I can make a good picture, or I can construct a good picture of the beam. Now I'm hesitating here because I'm looking around. I left myself over here without a straight edge, but I'll use this. I can trace the beam here. I could also have marked the reflected beam over here. And if I had, I could then trace the reflected beam, trace the beam path through the Mountain Dew, and then trace the beam path as it comes out of the Mountain Dew. Then if I use a straight edge or a ruler, let's see, I just got that one wet and I don't want to put it down in the paper. Okay. Using anything that makes a right angle, I can make a right angle up here with the tracing of the outline of the case. Then I can make a tracing here of the direction perpendicular to the case. And I can do the same thing here. I'm lining up with this part of the outline. Then I make my perpendicular by measuring the sides of the triangles that I've formed here. And I should be doing this with a straight edge, but in the interest of time I'm just doing it freehand. Let's see, I've got one more here. Okay, by measuring the two sides of this triangle, this side and this side, and this side and this side of this triangle, I can determine, using the inverse tangent, these two angles. I can do the same thing with these triangles. So I can determine the angle of incidence and the angle of refraction for the beam as it goes into the Mountain Dew, and then the angle of incidence and angle of refraction as it comes out of the Mountain Dew. Since these two sides are parallel and this is a straight beam, these two angles should be identical. And it turns out that if we follow the laws of refraction, these two angles should be identical.